this video is going to talk about one of the special right triangles that you need to know, called the 45, 45, 90. One thing I really want to basically note first is these are angles, okay? So these are angles in a triangle, okay? So whenever you say 45, 45, 90, you can assume already that two of the angles are 45 and then one of them is 90. And so what that automatically means is that it's also considered to be an isosceles, and this is going to be really helpful for you to solve like problems very, very quickly, just because you have to remember it's an isosceles. So let me go ahead and let me do a quick little sketch of it. I'm trying to do it, as accurate as possible, but not drawn to scale, whatever. So my 90 is right there, and then I can already say this is 45 degrees and this is 45 degrees, right? Notice the little dot there I added just for the degree sign. So since this is an isosceles, right, I already know that these two sides are congruent. And if you really want to think about why, well, it's the sides that are opposite the 45 degree angles. Let me go ahead and change color so you can basically tell, okay? So those two sides are considered to be congruent. That's why I have the little tick marks. And then obviously, right, we still have the hypotenuse side that doesn't change, and that is opposite the 90 degrees. Okay, so one quick thing that I do want to basically talk about here is, where the rules come from, because there's relationships between, this side and this side and this side. Well, obviously you should already know what the relationship is between these two sides, right? They're congruent because the sides are the same, and it's an isosceles. But now let me go ahead and basically tell you how to get to the pattern without actually, just straight up telling you. So what I want you to basically do is think about a square, okay? So a square, has 90-degree angles on all of them. That's where the 90 degrees is basically going to come from. And now to create this special right triangle, this 45, 45, 90, all we're going to go ahead and do is basically just cut it in half by drawing a diagonal. It's supposed to be a straight line, but whatever. So now what we're going to do is we're going to actually use numbers. So let's just choose any number we want to for these square, the side lengths for the square. Now, since it's a square, you know that whatever number I choose, let's say I choose 3, that means 3 is going to be on all sides. And what we're going to actually do is do the work to figure out, well, what is the hypotenuse equal to here? That's supposed to be a question mark, okay? So what the picture we actually end up getting is this one right here with 3, 3, and then 45, 45. The reason that this becomes 45 is because this line right here down the middle, we can call it like an angle bisector or whatever, a diagonal for a square basically cuts it in half, so it bisects the angle. And so then we have this triangle here, and remember what we're trying to figure out is what is that hypotenuse equal to, what is the length of the hypotenuse equal to. So if you really look at this triangle here, we're gonna go ahead and solve it in a way that at this point you should know how to do, right? You have a right triangle, you have two sides, and you're missing one of the sides. And we can do that using the Pythagorean theorem, which we know is a squared plus b squared equals c squared, where c squared is basically the most important one. That one is going to always be our hypotenuse. So just to make it easier, I will just make this one equal to x basically, just so the equation will have x rather than like a question mark. And in this case, it doesn't matter which one you let a or b equal to, because it's going to be the same number anyways. So I'm going to go ahead and substitute that into the equation. So I'll get 3 squared. Actually, you know what? I'm going to put parentheses, and that shouldn't be a 3. So 3 squared plus 3 squared. And I know for some of you guys this is super overkill, like you already know what the answer is, but just one step at a time. It doesn't matter. So 9 plus 9 equals x squared. We get 18. And then at this point, right, you should be able to know how to solve this this equation right here at the bottom. If you don't, right, the next step is to actually do square root on both sides. Okay, so we do square root on both sides because it's an inverse of a squared. Basically, think of it like they do the opposite functions. Whenever you square something, you square root it. And so now we end up with square root of 18. And then I remember, if you remember from units back, from a while back, this is where some of you guys actually kind of have a problem with, because this here, square root of 18, we need to break it down. break it down to the point where you have like number outside, square root, number inside. Okay. And so for those of you guys that do remember how to do this, or you just need a refresher, I've linked some videos in the description box, so you could go to it. But the way I'm gonna do it is basically just what I'm gonna do is I'm gonna break down to 18, right? It'll be 2 times 9. It'll be 1 times 18, and then I believe that's it. And basically all I'm looking for is the greatest perfect square root. 1 is a perfect square root. Okay, 1 is a perfect square root because the square root of 1 is 1. 9 is a perfect square root because the square root of 9 is 3. Since I'm looking for the greatest one, that means I'll use 2 times 9. So the way I do it is I'm going to break it down. So it'll be x is equal to, instead of writing 18, I'm going to write 2 times 9. And then I can break it down like that. Okay, and then after that, we can go ahead and use the fact that square root of 9 is equal to 3. Notice how I'm keeping the little like dot in the middle just to separate it. But you see how this looks weird? Some people might multiply that and actually get back like square root 6, which is super wrong. The 3 is outside. So what I'm just going to do is I'm going to move it to the front. So it'll be 3 square root 2 equals x. Okay. And so going back to the triangle in the beginning, right? This one right here, the green one. What I'm going to do is I know actually what this hypotenuse is equal to. It's going to be equal to 3 square root 2. Okay, so this right here is going to be the beginning of you kind of figuring out what the pattern is. All right, so what I'm going to do is I'm actually going to make a little table, right? And you should do it as well because it's actually going to be really nice. So this is what I'm going to end up doing, okay? I'm going to do this table here where hopefully you can see the pattern. So I'm going to put side length, okay? That's where I basically chose the 3. And then I'm going to put, well, what is the hypotenuse equal to? Okay? Now, we already did one example where I chose the side length to be 3, and then after I did the Pythagorean theorem, right, did the work for it, I ended up getting 3 square root 2. Okay, and that is our first example, basically. What you want to do now is on your papers, you're basically going to do the same steps, but now instead of choosing 3 to be your like square side lengths, you're going to choose whatever numbers you want. I suggest you keep them like 4 through 10. Just choose 3 of those numbers. Like just choose 3 numbers between the numbers 4 through 10. Don't make it really big because then this part right here is going to be really, really nasty, okay? So keep the number small. Maybe you want to choose 4, 5, 6. Maybe you want to do 4, 5, 7, whatever. You could even do 2 if you want, okay? But just that's what you're going to go ahead and do, okay? Do 3 different numbers. And then hopefully you can see what the pattern is going to be. And it's a really nice pattern, and it's really, really easy, okay? So try to do them. I will go ahead and do one more example in the video, and then I'll just go into the what the actual pattern is. So let's see. I chose 3. Let me choose a different number now. I'm going to go ahead and choose, this is my square. Let's choose, I don't know, 5, okay? So we start off with the square, and then I go ahead and I'm going to cut it in half. Or draw a diagonal, sorry, okay? It has to be a diagonal, not in half, because that technically is half, but that's not what I'm looking for. That technically is half, but that's not what I'm looking for. Because remember, I'm trying to form the 45, 45, 90. So here goes our 90 right here. Here goes our 45, because it ends up being a bisector. Okay, you got to remember that. Ends up being a bisector, an angle bisector, the diagonal. And so then I end up getting this triangle here, this right triangle. Again, that's super important. This side is 5, this side is 5, and that's the side I'm looking for. So again, Pythagorean theorem. All right, so let me go ahead and let me do that right here. So I'm going to put x just for the Pythagorean theorem. And then I'll do 5 to the second power plus 5 to the second power equals x squared. Notice how, remember, in the Pythagorean theorem, the c is always the most important one, which is always considered to be the hypotenuse, okay? So that's what I suggest you kind of do first, right? Figure out what your c is. So we end up getting 25 plus 25 equals x squared. We end up getting 50 equals x squared. My next step is just going to be to, sorry, that looks really bad, is to do the square root. All right, and then after that, the square root and the squaring cancels because they do opposite functions. And so now it's all about breaking down the 50. Honestly, this is probably like the hardest part of this entire like pattern, okay? So let's go ahead and let's break down 50. So what are all the different ways to multiply two numbers to get 50? And then we're looking for the largest perfect square root. Okay, so we'll start super easy. 1 times 50, which, I mean, at this point, hopefully you can tell that it's not really useful at all. And then let's do 2 times 25. We can do, let's see, does 3 work? No, 3 does not work. 5 works. 5 times 10. If you notice, we're kind of doing the thing that you guys used to do way back in the day when you used to do like 150, blah, 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 right? But I'm keeping them in pairs because when I break down the 50, I want to basically like, it's very quickly instead of like going back to the list and whatever. Okay, so let me see, is there any other numbers that worked that multiply 50? Some of you guys are really good at this. Some of you guys are going to take a long time. I suggest you just grab a calculator and just start multiplying. Let's see. I think that's it. I'm not entirely sure, but for this purposes, it's it because the answer is in here already. So what I'm going to do is I'm going to look for perfect square roots. 1 is a perfect square root. 25 is a perfect square root. 5 and 10, neither of them are perfect square roots. And so now that I've basically listed it out and I went ahead and I found my perfect square roots, it's all about finding which one is the largest one. 1, it basically doesn't do anything. It'll just bring me back to this like in a circle. Like that's all it's going to do. Okay, so that's why you don't want to use that one. So we'll use 2 times 25. If you're doing this correctly, the other number there, that one, you if you break it down, 1 times 2, it won't do anything else for you. Okay, like for instance, you would have to break that number down again and it'll become a little bit harder. I can give you an example on that, but for right now, let's just continue. This is 2 times 25 then. You can even write it as 25 times 2 if you want to, or make it easier for you, but you know, whatever. So here you go, breaking it down. And then this ends up becoming 5. Remember, I draw the little dot because I need to know that it's separate, but it's still being multiplied, okay? But the 5 does not fall in between or inside the square root with the 2. So it'll be 5 square root 2 equals x, and then that'll be right there, my answer. So what I can go ahead and do is for side length 5, my answer is 5 square root 2, okay? So I'm going to go ahead and go to my table. Where's it at? I lost it. Oh, here it goes. And when I did side length 5, I got the answer as 5 square root 2. And then for those of you guys that actually are trying to do it on your own, I hope you can tell what the pattern is. The pattern is, it's basically just going to be the number with the square root 2. So for instance, if I do 7, I know automatically it'll be 7 square root 2. If I do 9, it'll be 9 square root 2. Some of these take a little bit longer, like the 7 here, after we break it down. Let's see, it'll be the square root of 49 plus 49, which is, I have no idea. I'm going to go ahead and just try to do it in my head. Let's see, 49. It'll be 98. So you have to break down 98 and stuff like that. Okay? And so what I can actually end up doing is, let's say I don't know the side length. It's x. So what would be the hypotenuse then? Well, look at the pattern, right? You're using the number, the exact same number, with just the square root 2 behind it. So that's what we're going to go ahead. We're going to do x and then square root 2 behind it. Okay, so let me go ahead and let me draw it for you how you would see it like in a textbook or something like that. So this is the 45. Basically, if you really want to, this is the 45, 45, 90 rule here. Okay, so 45. Whenever you have side length x, remember that these two match automatically because we're talking about an isosceles. So x, the hypotenuse is always going to be x square root 2. Now, some of these can definitely get more complicated, just, you know, instead of me giving you like just a basic number like these here, I can give you like something a little bit more complicated, like a square root and stuff like that. And for those, you're going to have to look at the other videos, okay? But for right now, this is the basic pattern. You take the number that they give you for the side length, and then you basically just like tack on a square root 2 right behind it to get the length of the hypotenuse. It'll get way more complicated for different examples. So for instance, you know, let me go ahead and do a quick little example here. Wow, I thought I changed color. Okay, example. Let's say, for instance, I give you a 45, 45, 90, okay? And I say that the side length is equal to, the hypotenuse is equal to 8. And I tell you, well, what is that equal to? That's a very different problem. It's actually a little bit harder, and that's what you're going to have to go look at the other videos for. But that's just me trying to show you, you know, that it can definitely get harder really quickly. Let me show you another example where for some of you guys, you might think that it's harder, but it's actually not. It definitely looks harder. I will give you that. So let's say, for instance, again, I give you a 45, 45, 91, and I tell you, well, the side length is equal to, let's say, square root of 3. Well, what is the hypotenuse? Right? So you're still going to do the same pattern, right? And you have the side length. So you're just going to tack on a square root 2 behind it. And since both of them are square roots, we can technically go ahead and multiply them. And then that'll be our answer. Okay. So just this video is just trying to get you guys to understand where the pattern came from, which it's this one right here. Okay. You're basically just going to be using this over and over. Different videos have different ways of solving them. So just make sure you look at them.